Hello, everybody. Welcome to this new installment of component-based software development lectures, online lectures. Today we'll be talking about unit testing. And what is unit testing? So unit testing is an essential part of software development, and it's used to evaluate each code component. So far we've seen JSON manipulation, XML manipulation, API requests, web app development in the back end, the front end, and others. So to evaluate each component, each code component, to check if your function is performing as expected and to see how well it performs, we use unit testing. So we also determine how well this function reacts to valid or invalid input. So how you take care of some exceptions for these functions. And a regression suite of unit tests is also an excellent way of detecting unexpected changes in the code caused by refactoring or writing a new code. So when we say testing, it's the actual practice of writing code. So unit testing is, I'm going to write a new script file in Python and test functions and classes that are written in another script file. So what we are doing in testing is actually coding separate from our actual application, but we invoke methods from the original application in this new script to test and help determine if there are any errors. We need to be careful because it does not prove at all that the code is correct. Prove that a code is correct, the correctness of a code, of an algorithm, requires mathematical approach, and we use mathematical functions to prove that your function is correct or not. So this is different than testing. So what it does is to report if the conditions that the tester thought of are handled correctly. So testing is actually automated. We don't go ourselves and call the function during the test. This is what we do in debugging to make sure that we did correctly. What we do here is automate this testing. So the tests are run by the machine. So we write a script file to run these tests for us. So we can also call manual testing, which is when a human runs the program and interacts with it to find bugs. But this is a separate subject. So why testing? So we do testing to make sure that our code works properly under a given set of conditions. So testing assure the correctness just for these conditions, because syntax errors will almost certainly be caught by running tests. The basic logic of a unit of code can be tested to ensure correctness just for these conditions. So the goal here is, what conditions do I use? On what types of input do I test my functions? So we need to find a reasonably complete set of possible conditions to ensure that my code is working properly or working as expected. And also, testing allows you to ensure that changes to the code did not break existing functionality. So for example, we wrote a script called main functions that we used for the NASA example, we used for the AQI example, and that main functions is a base, is a foundation for all these applications. So what if I want to change something to these functions? Will it break the existing functionality? Will it affect my entire application? So that's why we test. In case you need to change something in a function, we make sure that nothing that is dependent on these functions will be affected negatively. So it's also used when refactoring your code, and without this test, you have no assurance that your code changes did not break things that were previously working fine, just like our JSON, XML, API requests. So if you want to be able to change or rewrite your code and know you didn't break anything, it's imperative that you do proper unit testing. And also testing forces you to think about your code under some unusual conditions, possibly revealing even logical errors. So sometimes we write functions, but we do not even think of what the user might enter. When you're doing testing, you think about all possible scenarios that the user will enter as input parameter. So thinking about this non-normal condition even makes you write better code. And that's and from that comes a principle called defensive coding that suggests that your code should be able to gracefully fail on an invalid input. So in case the user enters an invalid input, you don't want your application to break. You want it to send a message to the user, to show a message like a pop-up window, to give some feedback. But definitely, you don't want your application to break or fail. So that's why we say that your code should be able to gracefully fail on an invalid input. So this type of unexpected condition is what unit testing is for, to handle these conditions. And also, good testing requires a modular, decoupled code, which is the hallmark of a good system design. So the whole practice of unit testing, is made much easier by code that is loosely coupled. What is that? It's code that does not expose sensitive data, internal functions, and does not make use of these data. So this is a loosely coupled code. So if your application code has direct database calls, for example, testing the logic of your application depends on having a valid database connection available. So you need to be careful with this sensitive data when testing. Another important thing is, remember from the observer pattern where we had the weather station? What if I do not want to initiate that application, which means I do not want to instantiate an object out of that class weather station in order to test? You can create mock objects for that, which are fake objects, but still perform as a real object just for the purpose of testing. So these are the testing of a system design. It starts with the unit testing, where you test that each part of your code, for example, an XML manipulation, a JSON reading or writing, an API request. Remember, sometimes we made a request to an API and we got an invalid JSON file because our API key was wrong. So you want to be able to handle this type of things in the testing, because you don't want your application to read from a wrong, invalid JSON file. So in order to make sure that each unit of your code is working as expected, you run unit testing for them. So what do you want to do if the user enters the wrong API key? You want to be able to handle that. And once you're done with the units, you need to test if all the units interact among themselves correctly. And that's the integration testing, to check the robustness of the interaction between these units. And it also exposes defects in the interfaces and components. And moving up, we need to evaluate the software's compliance with the specified requirements of operating system. For example, will it run on these machines or not? How much of memory do I need for my application? And finally, the acceptance test. Did the user like my application? Does it meet business requirements? Is it acceptable for delivery? Does it meet all user needs? Another way to see these testing is in the shape of a pyramid. So you start with the unit testing, move to integration testing, and then an end-to-end test to see if it works for different machines, and finally the UI test for the user. An example in Python is assertion. So you can assert equality between two comparable objects. You can also assert if an expression is true or false. If two comparable objects are greater or equal, less or equal. Also, if an element is in a container object or not. If an element is none or not. If two elements are the same. Also, equality between sequences, sets, lists, tuple, and also if you raise the right exception on a certain function call, among other assertions. So now let's move to a coding example and see this more clearly. Hello everybody, welcome to this new installment of component-based software development online lectures. Today we'll continue on unit testing and run some examples in PyCharm. So let's give for example these function definitions: an addition that takes in a and b and return a plus b, a subtraction function that takes ab and return a minus b, a multiplication function that takes ab and returns a times b, a division function that takes a and b and tests if b is different than 0, it returns a divided by b. Otherwise, if b is equal to 0, it will raise a value error and print an acceptable denominator. Remember from school that the Euclidean distance between 2 points is the straight line distance between these 2 points. So in Python, to calculate the Euclidean distance between these 2 points, we need to define point 1 and point 2. Let's say that point 1 is a list, such that the first element of the list is the x value and the second element of that list is the y value. The same applies for point 2. So if you want to subtract the x values of these 2 points, you just access the first element of each one. The same apply for the y. So diff1 is actually calculating the difference between the x's, and diff2 is calculating the difference between the y's, the values of y. So for each one of them, I take to the second power and then add them and finally get the square root. In Python, the square root is just taking that value to the power of half. And this function returns the square root. So the next example here is to check if a number is prime or not. So in this implementation, first we pass number as an input parameter and we check if that number is less than 2. If so, we automatically return false. If the number is 2, we return true. And for any number greater than that, we test for all values of I in range starting in 2 all the way to the number. And if the remainder of the division of this number by I is 0, which means that the number is not a prime because it divides other numbers, you return false. Otherwise, you return true because the number only divides by 1 and itself. The other example here is from the class ELF. Remember class ELF? It was from one of the lectures in the beginning of the semester where we started studying JSON files here. So remember that this class has a constructor that takes in input level, ability scores that can be set to none, so the only required input here is level. And this input parameter is the value for the attribute level. And the value for attribute ability scores is this dictionary if ability score is none. So if the user does not input anything, so this is the default value for the attribute ability scores. Otherwise, is the ability scores passed by the user. The user provides one. And also there's an attribute hit point, which is 10 plus the value of ability scores for key constitution. The other example here is the factorial function. So if n is less than 0, you return 0. Else, if n is 0, you return 1 for the factorial. Otherwise, you call factorial of n minus 1 times the current value of n is a recursive function for factorial. So the name of this script file is unittestingonlinelecture.py. In a separate script, we are going to do the unit testing. We're going to run our unit testing. So the name of the script is test, and then the name of the original Python script that contains the functions I want to test. So inside this test unit testing onlinelecture.py, I'm going to import package unit test. That's the package that Python has to run the assertions. And I'm going to import all the functions and classes from this original Python script. So from unit testing online lecture, which is the name of this Python script, I'm going to import all the functions and class ELF. So I have the add, div, sub, molt, calculate Euclidean distance, the ELF class, factorial function, and isPrime. So what we do is we create a class that is going to test our functions, and you need to extend the class unittesting.testcase. So this is standard for the unit testing. You can only extend your class testcalc to unittest.testcase if you import unit test. And then inside this class, you're going to create a function to test each one of the functions you currently have. So let's say, for example, I'm going to write a function to test my addition function, my add function. Remember that the original function is called _add, and my function to test starts with the test keyword, and concatenate with the name of the original function. So let's say, for example, we assign the value of addition 2 and 3 to variable result. We can call the assert equal method from the unit test package to check if the result of your function passing 2 and 3 as argument is the same as 5. So you provide this 5 here, and you're going to test if the result is equal to 5. I just want to test if this function runs fine for 2 and 3. Of course, that unit testing, you would need a set of conditions much larger to test if your function works. The same for the subtraction. I want to test if my function called on inputs 2 and 3 is equal to -1. I want to test the equality of my function molt called on inputs 2 and 3 and check if it's equal to 6. I also want to check the division of 9 by 3 and check if this is equal to 3, and also an assert raises to check if the division of 10 by 0 raises a value error. To test if a number is prime, I'm gonna test, is prime here, is prime. I wanna test if 2 is prime, if 3 is prime, so I wanna assert true for these two values because I know myself that 2 and 3 are prime numbers. I also want to test 11 to assert if this is true, and I also want to assert false that the function is prime called on 4 should return false, and also function is prime called on input 6 is also false. To test the Euclidean distance, given 2 points 3, 0 and 0, 4, the Euclidean distance, which is the straight line between these 2 points, has distance 5. So let's call my Euclidean distance calculation function on this input and see if it's equal to 5. Some examples here, just as curiosity. We can try to assert that 12 is in this dictionary that contains key 1, key 2, key 3. I want to also assert if key 1 is in this dictionary, the same dictionary. Also, I want to test if this pair value, key 12, is in this dictionary. Also, let me test the list equality. Let's say, for example, if I want to see if this list is equal to this one. If 1, 2, 3 is equal to 1, 2, and if 1, 2, 3 is equal to 1, 2, 3. Also, I want to assert instances of my ELF class. So let's say, for example, if I want to create an instance of ELF, passing just first level as an input. Is this, to the constructor, is this an instance of ELF? Also, is this an instance of ELF by passing first value and a dictionary of values? Let me just remove these examples here. This was a mistake. So is this first level and this dictionary for the ability scores and integer 19 an instance of ELF? And also, is this instantiation that passes a string as first value, a dictionary of ability scores as second value, an instance of ELF? We also want to test if the factorial of 0 is equal to 1, factorial of 5 is equal to 120, and factorial of 10 is equal to 3,628,800. So in my main method here in Python, I'm going to call unittest.main. What does this do? This is going to call all the functions that starts with test inside my test calculation and run that automatically. Remember from the slides that this is an automated testing. So if you run this unit testing, you see that it ran 10 tests and there were 2 failures and 1 error. Okay, so the first error here is the instance of ELF that takes in first level, the dictionary of ability scores, and a string, and an integer. An integer. Is this an instance of ELF? It's not, because the class ELF, the constructor in the class ELF, takes 2 arguments, and 3 were provided. So if you remember the class ELF here, It takes level and ability scores that can be set to none. So definitely an object instantiated with first level, a dictionary of ability scores, and an integer cannot be an instance of class elf. And second, let's see this failure here. So we check that 12 is not a key in this dictionary. So 12 is not found in this dictionary. I only have key 1, key 2, and key 3. Also, these lists are different. Obviously, we're expecting them to be different, okay? So first list contains one additional element. So this is what unit testing gives you. It actually gives a pretty detailed explanation why the assertion failed. So let's go ahead and comment out in our testing here that this is definitely not an instance. Just passing first level is an instance of elf. Passing first level and the dictionary of ability score is an instance of elf, and that's it, because from elf I only have level and ability scores. So another error here that caused for us was saying that key 12 is the key in my dictionary, and also the list equality. Anything else I'm missing? Let me run here again. There's still one error. Oh, yes. So I don't have this as a key. Yes, I only have key 1. This is not found in my dictionary, this pair value. I only have key 1. So let me go ahead and check one more time. So I ran the tests, and now in 0.02 seconds, everything is okay. So what does this mean? The test in each one of these units independently gives no error. So my functions are working as expected. Why expected? Because I put the output value for a certain function. So I expected this value to be equal to my function column 2 and 3, for example. So all my tests ran okay. This is what you should see when you run the unit testing package.